Hello, everyone. Welcome to the Interview Hub. If you're preparing for a PySpark interview, you're in the right place. In today's video, we'll discuss the most frequently asked PySpark interview questions along with clear and concise answers. Before we get started, if you haven't watched our previous video on the top 5 most frequently asked PySpark interview questions, be sure to check it out. It will help strengthen your PySpark fundamentals and improve your interview preparation. Now, let's get started. What is a Spark execution hierarchy? Answers. PySpark program, your script that reads data and applies transformations. Action, the trigger point. Nothing actually runs in Spark until you call an action like show, count, collect, or write. Job. Every single action creates exactly one job. It represents everything needed to produce this result. Stages. Spark breaks the job into stages, and it only creates a new stage when a shuffle is needed, i.e. data has to move between executors, like in a group by. Tasks. Each stage is broken into tasks, with one task per partition of data. Executors. The actual worker processes that run the tasks in parallel, each handling its own partition. The vertical line connecting the icons is just reinforcing that this is a strict top-down hierarchy. Program, action, job, stages, tasks, executors, with each level being a breakdown of the one above it. What is a job? In Spark, a job is the top-level unit of work. Every time you call an action, an operation that actually triggers computation and returns a result, as opposed to a transformation, which is lazy, Spark creates exactly one new job to compute that result. Left side, definition and common actions. A job represents the complete set of work Spark needs to do to fulfill your request. It lists common actions that trigger a job: show, collect, take, count, write, save. Contrast, transformations like filter, select, group by do not create jobs on their own. They're lazy and just build up a logical plan until an action is called. Right side, example. 3 actions are called in sequence: df.show, df.count, df.collect. Since each is an action, each one independently triggers its own job. Job 1, show.show, job 2, show.count, job 3, show.collect. Total 3 jobs, because there were 3 actions, reinforcing the one job per action rule. Why this matters? This is foundational for understanding Spark's execution hierarchy, which typically goes job to stages to tasks. A job gets broken into stages, divided by shuffle boundaries, and each stage gets broken into tasks, one per partition. This slide sets up that hierarchy by establishing the top level, the job, and tying it directly to the action that caused it. This is useful for reading the Spark UI, where you'll see jobs listed by the action that triggered them, which helps with debugging and performance tuning. What is a stage? A stage is a group of tasks that Spark can run without shuffling data between executors, i.e. without moving data across the network or nodes. Spark draws a new stage boundary every time a shuffle is required, and a shuffle happens whenever there's a wide transformation. Left card, narrow transformation, green filter icon. Operations, read/filter salary greater than 50,000 /select name salary. Each of these is a narrow transformation, meaning each output partition depends only on data from a single input partition. No data needs to move between executors, so Spark can chain all these operations together into one pipeline. Result, one stage. Everything runs locally within each partition back to back. Right card, wide transformation, orange shuffle icon. Operations, read/+filter /group by department.count. Read plus filter runs fine as stage 1. Still narrow, no data movement needed yet. But group by department is a wide transformation. To group all rows with the same department together, Spark must redistribute data across executors/partitions, since matching rows could live on any node. This data movement is the shuffle. Because of that shuffle, Spark can't continue in the same stage. It must finish stage 1, physically move/write the shuffle data, and then start a fresh stage 2 to read that shuffle data and do the count. Result, 2 stages. Why this matters? Narrow transformations, filter, select, map, union, etc., are cheap. They don't cause stage splits. Wide transformations, group by, join, distinct, order by, repartition, etc., are expensive. They force a shuffle and therefore a new stage. Shuffles involve disk I/O and network transfer, so they're usually the biggest performance bottleneck in a Spark job. Understanding stage boundaries helps you spot where your job is expensive when reading the Spark UI. For example, seeing 2 stages tells you there's at least one shuffle happening. This ties directly to the hierarchy started in the last slide. Job/stages split by shuffles/tasks, one per partition within a stage.
What is a task? A task is the smallest, most granular unit of execution in Spark. The key rule here is a strict one-to-one relationship. Every task handles exactly one partition of data and runs inside one executor slot. So the number of tasks in a stage is always determined by the number of partitions your data is split into. Left 2 cards, the scaling relationship. 8 partitions equals 8 tasks. 100 partitions equals 100 tasks. This shows the direct, linear relationship. Partition count is task count. Spark doesn't decide task count independently. It's dictated entirely by how many partitions exist at that stage. If you repartition your data to have more or fewer partitions, you directly change how many tasks Spark will run. Right side, visual grid, T1 to T10. 10 dark boxes labeled T1 through T10 represent 10 tasks. The caption clarifies, each box equals one task handling one partition run by an executor. This visually reinforces that tasks are distributed out across the available executors, often in parallel, depending on how many executor cores or slots you have available. Bottom left tagline, every task equals one partition equals one executor slot. This is the one-sentence takeaway to remember. Why this matters, tying the whole 3-slide series together. Job equals triggered by an action, the whole computation. Stage equals a chunk of that job that can run without shuffling, split by wide transformations. Task equals the actual unit of work within a stage, one per partition, executed in parallel across your cluster's executors. Understanding this helps with real-world tuning. If you have too few partitions, you get too few tasks and can't use your full cluster in parallel, underutilization. If you have too many tiny partitions, you get excessive task overhead. This is why partition count size is one of the most common Spark performance tuning knobs, such as via repartition, coalesce, or spark.sql.shuffle.partitions. In this example, we have a 200 gigabyte CSV file split into 10 partitions is read, grouped by department, counted, and shown. df.read.csv.groupByDepartment.count.show. Step-by-step flow. Top row. Job 1, triggered by show, the action. Recall, every action equals one new job. Stage 1, handles read plus filter, with 10 tasks, one per partition, since there are 10 partitions and no shuffle needed yet. Shuffle. Because group by department is a wide transformation, data must move across executors, so all rows with the same department end up together. This shuffle is what forces the stage boundary. Stage 2 handles the aggregate, the countum after grouping, also with 10 tasks, since the shuffled data is still organized into 10 partitions. Bottom row, final tally. One job, only one action, show, was called. 2 stages, split by the one shuffle caused by group by. 20 tasks total, 10 tasks in stage 1 plus 10 tasks in stage 2. Why this slide matters. It's the payoff of the whole series, showing how the 3 concepts compose in a realistic scenario. One action equals one job. One shuffle equals 2 stages. 10 partitions per stage equals 10 tasks per stage, so 20 tasks total. This is exactly the kind of breakdown you'd see if you open the Spark UI for this job. It would show one job with 2 stages listed, and if you drilled into each stage, you'd see 10 tasks running against the 10 partitions. It's a great mental model for reading real execution plans and reasoning about where the expensive shuffle happens and how much parallel work is being done at each phase. Thanks for watching. Keep learning. Like the video, comment your questions, and subscribe to Interview Hub.